We will begin with the history of aquaculture. What is aquaculture, aka fish farming, which emerged for the demand of more fish? In this section, we will learn how aquaculture emerged and why. The first known written record of aquaculture is dated as far back to 2000 BC. The Japanese have reported to be the first to farm oysters 3,000 years ago. These two records prove how ancient aquaculture is. Because the fish that are fished from the ocean are hard to obtain, fish have generally been considered a delicacy food. However, the birth of aquaculture changed that. Returning back to ancient times, pictographs from the tombs of Egyptian pharaohs display people fishing for tilapia fish in man-made culture ponds. Also, oysters were cultured by the Romans 2,000 years ago and used aquaculture to grow them. These historical facts imply that aquaculture was practiced because humans favored fish, which created a demand for more supply. Though aquaculture was used for one's desire of more fish, it was also used because fish farming was more convenient because of location. Native Hawaiians built hundreds of coastal ponds that they flooded and stocked with marine organisms. Aquaculture was more convenient for them because of the abundance of water from the climate and from the Pacific Ocean.
Moving on, the government became more involved as aquaculture progressed. Similar to other forms of agriculture, aquaculture changed and became more industrialized due to advances in technology and the demand for more fish. The United States organized more research projects to produce rare fish, such as the buffalo fish. Eventually, the United States government enacted the 1978 Farm Bill, which acknowledged the practice of aquaculture and resulted in the creation of several agencies and programs dedicated to it.
Later on, the government became more involved and formed agencies for aquaculture. In 1970, the National Marine Fisheries reorganized as the National Oceanic and Atmospheric Administration, which placed aquaculture in a different spotlight when it became under USDA jurisdiction and the Agricultural Research Service. Both of these agencies emerged to further grow aquaculture, production, and regulated safety, and that the production met the demand of the fish market.
So what exactly is the current situation in aquaculture? The present situation in global aquaculture is almost like a yin and yang of the human condition. The yin, fish farming, has the potential to feed an enormous number of people in a world increasingly desperate for available protein. The yang, fish farming, may only be a partial solution because of its enormous impact on the world's critical energy and freshwater resources. Fish farming's growth numbers are staggering. In 1974, aquaculture provided a scant 7% of fish for the human consumption. By 2004, the figure jumped more than 5 times greater, to 39%, according to a 2016 report by the Food and Agriculture Organization of the United Nations. But that same report warns that by 2050, the global population can explode beyond 9.7 billion. That's a lot of mouths to feed. The question remains, is aquaculture one of the sustainable solutions to a world in need of protein?
Let's further consider the current situation of the world's available fish supply. For years now, overfishing has been a huge problem. Fish are being removed from the ocean at a faster rate than they can be replenished. At first glance, aquaculture would seem to be the perfect solution to overfishing. However, it's not that simple. There are two limited resources that are greatly affected by aquaculture: energy and fresh water. Both are in high demand in the aquaculture industry.
Then, there's the environment to worry about. An environmental concern often associated with aquaculture is the occurrence of oxygen-deficient bottoms, which occur because of eutrophication. Poisonous algae appears and spreads all types of sickness and parasites. The removal of oxygen ends up killing the fish. Fish need oxygen to survive. So, we're back to the sustainable yin and yang of aquaculture. Both the environmental yin and yang of aquaculture need to be carefully considered as the industry grows. Today, aquaculture produces at least 50% of the world's seafood, and that number will only continue to grow as the global demand for fish production increases. Aquaculture is dependent upon the species farm, the intensity of production, and the farm location. Although aquaculture produces food at an extremely high rate, it is negatively affecting surrounding ecosystems. The addition of solids and nutrients to the environment can cause potential environmental degradation and waste products. Lastly, two important yet limited resources are being used at a high rate due to aquaculture: energy and fresh water. We need to develop advanced technologies in the near future or potentially move aquaculture to the ocean if we want to keep aquaculture as something that's sustainable moving forward.
Like any form of industrial production, aquaculture has environmental impacts. The major impacts for the aquaculture industry include using more fish than they produce, disease and parasite transfer, the introduction and spread of exotic species, chemical pollution, habitat destruction, and the killing of predators that prey on the farmed species. To produce farmed fish, such as salmon, it takes about 3 times the weight of wild-caught fish. This is not only unsustainable, but also very dangerous to the population of wild fish species. Fish farms can also be a huge threat to surrounding ecosystems. Problems such as chemical pollution, waste, and escaped fish damage the surrounding habitat. Concentrated amounts of waste from the fish farms can smother the surrounding plants and basically wipe out entire ecosystems. Harmful chemicals, disease, and parasites can also be carried to wild fish nearby and cause the population to wipe out.
Today, about half of the fish we eat is farmed. It has been predicted that by 2048, stocks of all species of fish will collapse. This will cause us to rely exclusively on farmed fish. This is why finding a sustainable way to fish farm has become critical, and pretty soon we will have to depend on aquaculture for all of the fish we eat. In order for this to be achieved, these destructive and harmful methods of aquaculture have to become sustainable and environmentally friendly. The health of our oceans, rivers, and lakes are at stake, and so is our own health and economic well-being.
Our proposed solution to make aquaculture more sustainable is a combination of integrated multi-trophic aquaculture systems, also known as IMTA, and aquaponics. Recirculating aquaculture systems, or RAS, used to be seen as an ideal solution. However, studies have shown that they actually still have negative impacts on the environment. While RAS is very similar to IMTA and does share some of the same benefits, water quality in an RAS becomes lower over time, especially due to the buildup of heavy metals and fish waste, and must be discarded, eventually contaminating the environment.
An IMTA system corrects the faults in an RAS by creating a miniature ecosystem with a fed species, an extractive organism which consumes the nutrients and waste of the fed species. For example, a system could contain fish, seaweed, and abalone. The abalone feeds on fish waste and seaweed. The seaweed uses and filters fish waste nutrients while restoring nutrients and oxygen to the water. Another example of IMTA system include tilapia and lettuce, shrimp and vegetables, and carp, spinach, and snails.
In an aquaponics system, plants are grown in beds of gravel inside a greenhouse with water from the ponds running through the beds. The plants and the gravel help to further filter and purify the water. An IMTA and aquaponics system halves the amount of water needed to produce fish and crops. In addition, there is no wastewater since many of the waste nutrients are taken up by the extractive organisms or plants, as well as filtered through the gravel.
Unfortunately, such a system will be difficult to implement due to time and costs. Research is still needed on the conditions and ideal species for IMTA systems. It also takes a long time for fish farmers to switch over or start a new system, as well as for the crops and fish to grow, resulting in a loss of profit for the farmers.
There are a lot of expenses to take into account for fish farmers starting with IMTA and aquaponics or switching to those systems. They will need to pay for the construction of the ponds, the machinery to set everything up, like pond, greenhouses, piping systems, the materials for the system, and the labor they hire. Long-term costs include power to keep everything going, water, and oxygen.
However, there are some benefits for the fish farmers, including reduced water and oxygen consumption, an increase in products, cleaner water, and healthier fish. Some disadvantages are a reliance on the shifting market price of crops and less fish produced overall. Unfortunately, unless fish farmers are required to reduce their environmental impact, they are unlikely to want to change to a new system due to the time, high costs, and potential loss of profits.
The IMTA system will have a great impact on the amount of water used for aquaculture. The amount of water used in IMTA systems is less than the amount of water used by traditional sprinkler systems to grow crops. This is due to floating boards to prevent evaporation of water and plants cleaning water for the fish. Use of less water will keep this option open to water-restrictive regions such as California. While current systems now, like RAS systems, suffer from high water prices, IMTA systems will have a lower operating cost while having the benefit of growing 2 products for the price of 1.
If the IMTA systems are not used and traditional systems like RAS are used, it would affect the environment and the economy. One major issue for the RAS systems is that you need to discharge water to get rid of excess metals and contaminants. This is an issue for keeping our freshwater clean because discharging water from RAS systems could affect ocean fish communities and our coastlines. Also, using the system would require more water and would drive the price of water up, limiting it to certain locations.
Another current method of using coastlines to produce fish has had effects on the environment as well. Using open waters to grow fish can put strain on the local ecosystems and puts local fish populations at risk of disease. In addition, the farmer will lose control over the quality of his or her product.
The IMTA system is the most promising development for aquaculture sustainability. The most difficult factor that will have the biggest impact for aquaculture is how this technology will be used. Mass production of food across all of agriculture has impacted our environment and economy, so we must use this technology responsibly to ensure a brighter future for generations to come.